Okay, fine. So the recording has started. So let us first share our screen and talked about our previous class little bit, and then we go for our um, today's session. Of course, it's a good productive session, and I hope that everybody will keep note and ask question whenever you think it's necessary. Okay. So this is our last class. We started with FX size basic meta-analysis calculation. There are so many things that we need to cover in this 6 weeks time, but first of all, we understand that from SLR to meta-analysis journey. Can you see what I am writing in the board? Is it visible to everyone?
Yes, sir. Yes, sir.
Okay.
Yes,
So
sir.
okay, so basically, the systematic literature review and meta-analysis is a part of our um, total literature review or review of literature. Now, at the very beginning of the class one, we have discussed about how to write a systematic literature review based on the protocol, based on the FINER math criteria to decide the first title of the research, then the research problem, how to identify the research problem. And based on the research problem, we try to search the data for meta-analysis. So what meta-analysis actually shows is the synthesizing the statistical information, synthesizing statistical information of the research problem that we are investigating. For instance, if I say that is there any positive outcome from the drug that I have used? And this drug that I have used in my sample previously, other researchers in their own perspective, what are the results that they had in their outcomes of different statistical analysis. We need to synthesize those results, and accordingly, we try to see what my results, whether it is aligned with the results that the previous studies or it is different. So the most important outcome of the synthesizing of statistical information from meta-analysis is that whether our results are homogeneous to the previous studies that has been published earlier, or heterogeneous in nature. Even though there are maybe heterogeneous in nature, in the meta-analysis results, your results might be heterogeneous, meaning they're different what the others have found from their results. However, we can say that what is the rate of heterogeneity, meaning that if the rate of heterogeneity is severe, then we may say that the policy or the drug that we are trying to establish for this particular community is not a good idea to apply, because previous studies, they haven't supported my results, or this is a great variation among my results and the other result that has been published earlier. So that is a very significant outcome, because uh, by by doing that, we actually doing a real life policy analysis, real life application of the medical science, social science application. So meta-analysis is a very strong research methodology. At the same time, it gives you a very clear idea what about the historical information, whether it is supports or not, because we need to see that how many percentage of the previous studies are aligned with my results, or at least previous studies, meaning that the concurrent studies, let's say you are studying from India or from Pakistan or from Bangladesh, but someone studies from, let's say, European Union and America, and they have published article based on their findings, and we would like to see their findings and my findings from different sample sizes are aligned, which means homogeneous in nature, or heterogeneous in nature. If heterogeneous, there is no problem. However, the rate of severity is important, and that is what we are going to measure by meta-analysis and its statistical tools and technique. So that is the idea of the meta-analysis, why we are interested to do meta-analysis. So The idea is very simple. We would like to synthesize the previous and concurrent studies, statistical outcome, and find out the basic results, whether it is aligned with or different with my information that I have published in or I have investigated with my sample size. Now, while doing that, as you know that there are when we are doing the SLR, systematic literature review, and as I told you, the journey is from systematic literature review to meta-analysis, right? Now, let's assume that we are talking about 50 studies, and from these 50 studies, we are trying to find out the mean and standard deviation or sample size of different studies. Now, as you know that the study's sample size may differ, and therefore the standard deviation also it differs, and the mean results, meaning that the the one that we are trying to say, the drug outcome, probably that findings might, the mean, the average value of that findings might be different from 50 different articles. Now, how do I make a one single uh, structured criteria or indicator or statistics to analyze the impact of these 50 studies from one single indicator? In order to do that, we try to calculate the effect size. Effect size. It is the single most important thing in the meta-analysis. Now, dear learners, what we do actually with the effect size is that let's assume that we have X bar 1. This is study one mean of any outcome that we are talking about. It might be a calorie intake. We say that it's a calorie intake, the average calorie intake the community receives from your sample in order to study whether they are suffering from malnutrition. And study 2, let's say study 2 also have a sample mean of x2. Likewise, we have n number of x3. These are our different sample mean values. Now, what we can do is that we actually summarize all these sample means, and divide it by the number of studies, and we will have a weighted mean or the weighted average mean of these whole things. So what we get, what we have a single weighted value. We can say that a weighted value. Okay, we can say that a weighted value. And now what we can do is that now we have this mean x bar 1 divided by the weighted value that we have found from this calculation. And once we can once we divide the whole things like x3w by the weighted value, we will have a adjusted mean. The adjusted mean, or we can say the effect size, or we can say the effect size. This is effect size 1, this is effect size 2, this is effect size 3. So it is the single most or the simplest way to understand how the effect size work. So first column, we have different mean value, and then we summarize the mean. I mean, the whole mean we sum and then divided by the number of studies, we got a weighted value. And with this weighted value, we adjust every mean with this weighted value so that we can have a uniform value from each of these studies, because we are adjusted with the weighted value. Therefore, whatever we have found, this is effect size 1, effect size 2, effect size 3. So this is the simplest, most effect size that we can calculate from a simple single group mean, standard deviation, and number of sample size. And why we need this? Because as I told you that we need a common ground to calculate the homogeneity or heterogeneity of the studies. Okay. Now, these studies, whether it is a homogeneous or heterogeneous, we can only find out if we first calculate the effect size and then we know the number of samples. Okay. Or also, you can see that the standard deviation is also very important. What standard deviation shows that how much the sample size and the value of the individual numbers are depreciated or from mean to standard deviation, how it actually associated, how it divert or deviated from the mean. So that is also standard deviation is also important value. So that we can also put instead of a number of sample size, we can say standard deviation and then effect size. We can calculate the homogeneity or heterogeneity. Some cases we see that you also very familiar with the term called the standard error. Okay, this is also an important criteria to calculate whether the values are heterogeneous or homogeneous alongside with the effect size. So this standard error, meaning that the sample size, the probability sample size difference, meaning that every studies has their own sample size, and the sample sizes are differ from study to study due to the probabilistic reason, because all these are the sampling distribution. We are for putting it in a normally distributed bell-shaped curve. So in one word, we say sample one and sample two, their deviation from the mean is depending on the standard error. Okay. And standard deviation is just from the mean value to the value of a single entity, the deviation from mean value to the single entity. Whether standard error means that sample size 1 and sample size 2, these two have two different mean, let's say mean x bar and mean x bar 2. So what is the difference between these two sample size means? How deviated from one sample size to another sample size, we measure it by standard error. So either of the standard error or the standard deviation, depending on our research question and the availability of the data, we can collect and design our study accordingly. Now, if I wrap up the initial understanding that first of all, we need a systematic literature review. And from this systematic literature review, we may have 50 articles. And in these 50 articles, probably talking about a single group study where different articles are talking about the malnutritious children and their calorie intake. So the calorie intake probably the most important indicator of those studies. And every study has the average calorie intake. So the average calorie intake, we refer to the mean. And once we have the mean, also in a descriptive statistics, we might have standard deviation and also the sample size. From a very basic and simple way of understanding the meta-analysis is we first write the number of mean outcome from different studies, then divided by the mean by the number of studies, we got the weighted value, and then we adjust all the means by the weighted value, and then we get the effect size. And we will try to use this effect size to find out the heterogeneity or homogeneity nature of the study that we're talking about. And also, the important two other things is that when we are calculating homogeneity or heterogeneity, we need number one, effect size, and number two is either standard deviation or standard error. Okay, so it depends on the study. If it is talking about single group study, in that case, standard deviation is the most preferred indicator. If there are two sample size, or maybe we're talking about a control group and a treatment group, probably multiple group of studies in one single research article. In that case, we are trying to find out the standard error of that particular article. So probably every article will report the standard error if there is a multiple group of sample like this case, or if it's a single group study, then the study will report only the standard deviation. And the question is, doctor, once we have found these things, basically how we can calculate the homogeneity or heterogeneity. So there are two methods that we use to calculate the homogeneity and heterogeneity. One is called the random effect model, and the other one is called the fixed effect model. And there are so many other models like maximum likelihood method. We will try to understand those things, and also Bayesian way of calculating homogeneity or heterogeneity. Those things we will try to find out very soon, and we will study during the 6 weeks time. As I told you that we are talking about from basic to advanced, and this course is a holistic view of meta-analysis, meaning that each and every model, each and every analysis we will do in this particular course to understand the meta-analysis, the very best way, the possible best way that anyone can give you in any parts of the world. So that is our objective in this particular course. So the random effect model and fixed effect model, these two models decide whether the values that we have, the effect size together with the standard deviation or standard error, gives us a homogeneity among the studies or heterogeneity among the studies of the findings. Usually the effect size, usually the fixed effect method talks about that study to study, the study 1, study 2, and study 3, there are not much variation. The variation comes from only the sample size variation, like the sample size 1, sample size 2, sample size 3. So these are the variation coming from the sample sizes. However, the random effect model, it says that within the study, meaning that this study has their own variation, this study within, I mean, between and among and within the study. So if I look at the random size calculate within the study variation plus between the study variation, between meaning that study 1 and study 2, this is study 1 and this is study 2. So it will measure the variation of homogeneity or heterogeneity between the study and within the study, because in the within the study, the studies are result comes from for the different sample sizes. It might also, the sample size can affect the average value, so that also captured by the random effect model. However, the fixed effect model, it does not talk about within the study variation. It actually focus on the between the study variation, meaning that study 1 and study 2, how they are differ, and therefore the model of fixed effect is focusing on the between the study variation, whereas random effect model, it focuses on within the study variation plus the between the study variation. So if I would choose which model is appropriate to find out the actual homogeneity and heterogeneity, which model we would prefer? Who can tell me? Jackie, which model in this case is better?
Random effect.
Random effect. Yeah. Jackie, do you understand what I'm saying?
A little bit.
Okay. So I will share all this information with the recording and your CC. Don't worry about it. But you need to
Yeah.
ask question as well, okay? Because it is important while we are discussing anything. If you don't ask any question, then how do you know? How do you understand and how do you learn from this activity? Okay?
Okay.
Okay. So the effect size in this case is
Sir, I want to ask one question.
yes, Palash.
Sir, in what cases, like, can you give an example where we prefer fixed effect over random effect?
Okay, I will discuss that part later on, but just to generalize the view, 90% of the cases, 90% of the cases, we prefer random effect model, and 10% cases, we prefer fixed effect model. Usually, a single group study usually prefer a mixed fixed effect method, because a single group study, since it's only one group, for each of the study reporting single group. So there is not much variation within the study. So it is better we focusing on the between the study. The fixed effect model is more preferable. However, when there is a control effect and treatment effect and randomized control trial methodology in each of the studies, so there is a, of course, chances of high that within the study there are some variations. So in that case, of course, random effect model is preferable. So therefore, most of the cases, to be safe, to be safe side, we use random effect model. 90% of the cases we use random effect model, and only 10% cases we use fixed effect model. Is it clear to everyone? Any question? If you have any question, you can ask. There is no question called silly question. You can ask any question. Okay. Okay. So very good. Now, let me share one of the data set before we go to the discussing this slide. Let me share a data set. Okay. Let me share a data set. So the data set. Okay. So this is the data set. You can see that this is the data set. Can you see the data set, my dear learners?
Yes, sir.
Yes, sir.
Okay, so you see that this is called the single group studies. Single group studies. And these single group studies, we have mean, standard deviation, and number of sample size only. Now, if I open the JAPS, let me share the JAPS. Okay. Okay. So this is the opening of the JAPS. So let me see. Okay, let me save this data. Save this data set in my download. Download. Okay. So I will upload it using the JAPS from my computer, browse, and see the samples of data set. So we have this data set. Okay. Now I go to the meta-analysis. Meta-analysis. Okay, this is our meta-analysis. So we go to the effect size computation. Click the effect size computation. Okay, so we click the single group. Now, are you looking at the single group, my dear learners?
Yes, yes.
Okay, so you see that
Yeah.
here it says mean, standard deviation, and sample size. So if you put the mean value, standard deviation, and sample size, you can calculate the effect size. And once you calculate the effect size, my dear learners, then we go to the classical meta-analysis. And if you look at the classical meta-analysis, if I click the meta-analysis from classical point of view, you see that this box shows the effect size standard error. Okay. And then you can calculate, because you see from here, the method shows fixed effect method, maximum likelihood method, Dar-Simon's Layard method, Hunter-Schmidt model. So basically, apart from the fixed effect model, we use restricted ML, maximum likelihood. The maximum likelihood is also referred to the random effect model. We also can calculate Dar-Simonian layered model. This is also one type of analysis to find out the within the effect and between the study effect or homogeneity or heterogeneity. There are so many other models available. We will try to understand one by one, but initially we need to understand either we use the fixed effect, which is 10% of the cases, and or restricted ML or maximum likelihood. So these are the two important method we can use. And by default, restricted ML is given. So people usually have these type of method because method used to estimate. If you click, if you hover over the value, you can see that it gives you the direction method used to estimate heterogeneity. In the meta-analysis, the available methods depend on the inclusion of the studies. You see, inclusion of heterogeneity model terms. So basically, it measures the heterogeneity. So if I go to the maximum likelihood method, similarly, maximum likelihood method is also available depending on the inclusion of heterogeneity model, meaning that it also measure the heterogeneity or homogeneity. So basically, these are the important issue. Now, fixed effect test, we have Z-score, t-test, and Kanha. We can say we can prefer Z or we can prefer t-test it depends on what we are actually trying to find out from the value. And this also adjusted value. Kanha means the Knapp and Hunter adjusted value. So this is also an important indicator of how the results is distributed among the heterogeneity. So heterogeneity comes from a distribution, whether it is a normally distributed heterogeneity or a abnormal skewed heterogeneity. It depends on that. So we will try to measure that as well. So we are not going to do that at this moment. At this moment, for today's class, our main focus here is to understand, to calculate the effect size calculation. So you can, if you look at the effect size here, our studies, if you look at the study names like fitness study, baseline strength, cancer screening, depression, there are so many studies. It's just a hypothetical study that we're talking about. It's not a real studies. It's a hypothetical study, and their sample sizes are given, mean outcome are given, standard deviation are given, and study type are given. So study type is not that important, but however, we can always use. Now, there is a difference. Let me share it. Okay, so there is a difference here that here it says that a baseline single arm meaning that a single group study. Single arm means that single group. Okay, arms means how many group that we are talking about. For instance, there are usually two group in one study. If it is a RCT study, one is the control and the other one is the treatment group. So if RCT study, randomized control trial, in each of this study will have control group and treatment group. However, since in this case we are talking about only talking about the single group study, so you see that there is no arms here, all arm. Okay, basically one single understanding of the group that we are talking about. So it is very simple to understand. And these slides and the notes I will provide today after the class. But today also, I want my students to get a calculation, the effect size calculation with this important analysis. Okay, so let me go to the slide again to just to check what we are trying to see in this particular case. Now here you see that the effect size matters when there is a difference between p-value says what is significant or insignificant. Effect size shows how big is the difference within the study and between the study. That is the effect size. Cohen's d is one of the name of the effect size. There are several name of the effect size. One of the simple effect size, the effect size is the single group effect size mean. Okay, mean is the one effect size name. Only mean, single group study, which is effect size comes from the mean. Sometimes effect size come from the mean difference. Let's say the control group mean and the treatment group mean. The control group mean and the treatment group mean. So there are difference between these two mean, and that is how what we calculate by Cohen's d. Cohen's d is the effect size. So this is the effect size when we have a two arm, one is control group and the treatment group in one single study, and their difference of the mean we calculate, we find out the effect size. That is what we call the Cohen's d. Also, you find out that there is a binary study like yes or no. In that case, we say odds ratio is an effect size. Odds ratio is also effect size. And then we have correlation value. Correlation value, like there is an association between two variables. That is also an effect size. Risk ratio. This is also an effect size. So effect size can be coming from different analysis. One, the simplest, most analysis is the one that I have shared with you, the mean. But there are other effect size that we can calculate from the research studies, depending on the research question and research problem. For instance, odds ratio, correlation values, and risk values, and we can calculate from those values to effect size. Now, as you know that we need effect size and standard error to calculate the homogeneity and heterogeneity of the studies. And before doing that, we need to calculate the effect size itself, right? So if you look at these information, as I told you that JAPS is a fantastic software. If I go to the effect size calculation, you look at this variable association, meaning that we are talking about the correlation. So you see the correlation value, sample size, okay? Then if I say repeated measures, we say mean 1, mean 2, control group, the treatment group, okay? Then if I say that others meaning that coefficient of alpha, maybe we are talking about a regression. From the regression, we have coefficient values, right? So we can put that as well. Then we have reported effect size, like already effect size is mentioned in the research. They already calculated the effect size for you. If that is the case, then you can directly collect the effect size. No need to calculate the effect size. You can directly extract the value from the effect size from the studies. And see, there are so many independent groups, mean differences. You see standard mean differences, SMD, okay? And you can see that risk ratio. So there are so many things. We have binary. If I say I'm talking about binary, meaning that odds ratio, we have odds ratio, we have AS, Pareto. There are so many other ratios what there. So a risk ratio, RR, means risk ratio if the measurement is binary. If the measurement is counts per time, we have these events, how many times it happens in one count. And then we have quantitative nature, usually quantitative nature in this case, this one. So measurement of binary, counts, mix, and quantitative, depending on that, designing of the studies, like we are talking, the research question is based on the single group study, variable association, repeated measures. There are so many things are there before you can go and analyze your effect size. So first thing first is going slowly and understand it clearly. It will help us to, getting the things in our mind, because it is very difficult to understand meta-analysis. Meta-analysis is very interesting, at the same time very comprehensive methodology and very effective. And nowadays in the AI era, it is one of the most popular, because in AI, without the meta-analysis real data, you cannot take AI, you cannot say AI to collect the data for you. It's not possible. You have to manually do that. And you can extract the data from Notebook LM. However, you have to download the articles manually and genuinely, originally, and then you collect those information using different AIs for the effect size. Like for the single group cases, we collect the mean, standard deviation, sample size, like that. And you can see that in this case, if you look at the meta-analysis from JAPS, JAPS has a database of previous meta-analysis. This is called the Cochrane meta-analysis database. And you can see that there are continuous outcome and dictonomous outcome, meaning that binary outcome studies. So many studies, hundreds and thousands of studies are already installed in this particular software. So JAPS is a comprehensive understanding of the meta-analysis. No other software has this type of huge things, both in classical and Bayesian perspective. So it's a very interesting, and we will study this hopefully in this course. So again, I go back to my slide where you can see that the Cohen's d formula, you can see that the formula itself showing very clearly that in the Cohen's d, meaning that the standardized mean difference of two different groups in one single study. So if you look at the information that is mentioned over here, that x1 is the mean of the treatment group, and we have y1 is the x2 is the mean of control group, right? Mean of control group and mean of treatment group. So this is mean of control group and mean of treatment group. So two different results, two different part of the results. You can see that, and the standard deviation pooled standard deviation, how to calculate the pooled standard deviation. So if you look at the pooled standard deviation, this is how it calculates number of sample sizes minus 1. And this is very simple to calculate. You can use it by using manually, you can do that, or there are so many way you can calculate the standard deviation. To calculate the standard deviation from the data set. So you can see that n1 minus n standard deviation square 1, because this information has to given you standard deviation 1 of the group number 1, mean group treatment group standard deviation 1, and standard deviation from mean group of control group. This will be given to you, and number of sample size will be given to you. From there, one single standard deviation you can calculate very easily. Okay, one single standard deviation you can calculate very easily. So that is what we have in this standard deviation calculation. Now look at the next one. If I go to the next one, here you can see that an example given here. The treatment group here 60 and control group 60, mean anxiety, the two different groups mean, and the standard deviation reported. And this is how you calculate the common or pooled standard deviation. You can see that how it calculates. And then you have your effect size, which is called the Cohen's d is your effect size, and standard deviation you can calculate. Now, standard error, measuring the precision. Standard error is the measuring the precision. Okay. So in the standard error, different studies have different sample sizes. That's what I said. Okay. Different studies has different sample sizes, and these sample sizes, larger studies provide more precise estimates. Standard error tells us the range of plausible values. So how these sample size differences, two sample size from two different group, let's say from one study 1, article 1, there are two sample. One is for the treatment group sample. The other one is the control group sample. And how these samples are basically differ from each other, it actually measured by the standard error. Now, how to calculate the standard error of the Cohen's d? As you know that in the calculation, we see that for random effect calculation or fixed effect calculation, we need an effect size. At the same time, we need a standard deviation or standard error, right? So if it is one single group, we focus on the standard deviation. If it is a multiple group in one single study, like treatment group and control group are given in the one single study, then we go for a standard error for our homogeneity and heterogeneity calculation using random or fixed effect model. So in that case, if there are two different groups are there in one single study, in that case, the standard error calculation can be done by number of sample 1 and number of sample 2. And this is how we can calculate. D square is the difference between the two studies mean. D square is the difference between the two studies mean. Difference between the two studies mean. So that is how you can calculate the standard error when there is a two group of study in the one single form. So you can see here that this is the calculation study. Now there are some random effect and the fixed effect. We will already explain that, and hopefully we will do that in coming days as well. Understanding heterogeneity, reading a forest plot, we will discuss those things slowly and gradually, hopefully, and how to write the results. Also, we can do that. And in the class 3, we also discuss about a little bit of binary outcome like odds ratio. We have risk ratio. Then we have correlation value. How to make a correlation effect size calculation. We will do that in this course as well. Now, my dear learners, what I would suggest that let us do a practical work. Okay, so now I'm sharing in my group this study material. Let me share it with you. Single group file. Okay, so I shared it in the WhatsApp group. Okay, what you have to do is just copy the whole thing and put it in one single Excel file. Do not put these things, because if you keep these things top of the Excel file, the JEPs won't read your result, read your values. Like for example, here these things, the empty cells are there. Why? Because we put some things up front of the Excel file. So delete those things and keep this first column name like this and calculate the FX size. Can you do that for me?
Okay, could you, sir?
Yes.
Yeah, could you show me, show us just how to calculate it,
Okay. Very
please?
simple.
The
Yeah.
effect size.
Yeah, very simple. First of all, you upload, let me share it.
Yeah.
First of all, you go to the JAPS, because I think you already downloaded the JAPS, right?
Okay.
So go to the JAPS
Yes.
and then open and go to the computer and browse the data set that I give you. Okay, for example, this data set. Okay. And remember, before you upload the data set, as I told you, delete the upper part of the Excel file where I put the name, that single group study and all those things. Just delete those things. So the name of the variable, like study name, standard deviation, mean, will be the first column name, meaning that these are the variable name, right? So you start with that, okay? So little bit of correction of the data set, and then you upload the data into the JAPS file. Once you upload the data file into the JAPS software, then you go to the meta-analysis and you see there is a first called the FX size computation. You see that, Asifa? FX size computation. If you look at the FX size computation,
Yes.
click the
Yeah.
FX size computation. Once you click the FX size computation, JAPS will pop up with the FX size computation like this. Okay. So now, as we are doing a single group, select the single group. This option, single group, and we are doing a quantitative study. So put it like this way, quantitative study, and our FX size is like single group mean and number of samples. So keep it like this way. So single group, quantitative, SMN, and we have mean, standard deviation, and sample size. Our data set has the same things, mean, standard deviation, and sample size. With that, I want you to calculate the FX size of this data set. Can you do that for me now?
Okay, please. If we should give every manually every means SD and all.
No. You share your screen now. I tell you and you follow my guideline, okay?
Okay.
First, you open the data set.
Okay, one more.
Share your screen and open the data set.
Yeah. Just. Yes, I'm cleaning that data.
Okay, sure, no problem. But you can also clear the data in front of us so that
Okay.
everyone can see it.
Okay. Just a minute. 1 minute.
Yeah, sure. Take your time. Take your time, no problem.
I think you can see my.
Yes. Desktop, I can see your desktop.
Yes.
Okay, so.
So first you show us the data.
Okay, data, okay. Yeah, this is data.
So now you see that, can you make it a little bit larger? Okay. Now you see, Asifa, in this data set, we have three different sheets: FX size calculation, JAPS instruction, and advanced analysis, right? We don't need that. because it
Okay.
is a sample instruction file for you, but we don't need
Okay.
that for calculation. What
Okay.
you can do, go to the data,
Mm-hmm.
okay, open a new Excel file, open the new Excel file, click the new,
Okay.
okay, now click this one, click now the upper side, yeah, this one, right? Open the new
Okay.
Excel file. Now copy the data into this Excel file,
Okay.
the data only. Yeah,
We
from
need the first column with the
yes,
study.
yes. The name of the variable. Copy it
Yes.
and paste it. Right click. Nice.
Yes.
Fantastic. Now, what you can do, save this file either as Excel or CSV, whatever you can.
Yes.
Save this file. First browse and yeah, desktop. Yeah, that sounds good. Name the file as the class 2 demonstration. Class 2 single group meta-analysis demonstration. Class 2 single group, yeah, meta-analysis demonstration. Demo, right? Very good. Nice. Just save it. Fantastic.
Yes.
Now, now you go to JAPS. Now you go to JAPS.
Tabs.
Yes, click.
Okay.
Yeah, now go to the open from computer, browse,
Okay.
browse, yes, browse. And then from desktop, you choose the data, this one. Yeah, click this one.
Okay,
What it
1
says,
minute. I need to
yeah,
close. Okay.
okay. So it will open up like a new window.
Yes.
Yeah, nice. Now we have study name in the first column, study
Yeah.
ID, name, sample size, mean, standard deviation, study type, right? So now you
Yes.
go to the meta-analysis, click the meta-analysis, go to the effect size computation, click the effect size computation.
Yes.
Okay. Just hold on a second, it will come. Yes.
Mhm.
Now
Yes,
you go to
okay.
the single group, click the single group,
Mhm.
and then quantitative is fine. Now you see that mean is given, right? So from the
Yes.
drop down,
Mhm.
double click the mean. Just arrow sign to the mean. Yeah, very good, fantastic.
Yes.
Now standard
Okay.
deviation, similar way the standard deviation. Fantastic. Now sample size. Excellent.
Okay.
Now you are done with your effect size calculation.
Okay.
Okay.
Fine.
So your
Okay.
effect size is calculated. Okay.
Mhm.
Now you see that the effect size is calculated already. Now it says, is there any subset or study level? So you have to put the study level. Go to that study level. The name of the study name variable. Yeah. Go to the study level. Just drag and drop it.
No.
What happened? Minimum number of numeric values is 1. Study ID, study names, study type. We don't need study type. Can you go to the study ID? Yeah, then drag it, drop. Drop down what it says. It's supposed to give you study. Okay, subset, go to the subset. Subset, study name, click the study name. Yeah, go to the subset. Study name. Yeah, it's done now, right? Now, anxiety disorder, okay, initial subset, go to the subset level. Okay, click this one. Okay, so here there are so many things that we can calculate from this study, because these studies depending on the studies are depending on the blood pressure, anxiety, cancer screening. Go to the Excel file. This is the list of there, right?
Yes.
Go to the Excel file. You see?
Yes. Okay.
The study names are like this, right?
Yes.
Cancer screening, depression, blood pressure, sleep quality,
Yes.
right?
Yes.
These
Yes.
are
Correct.
the names. So our go to the JAPS again. Go to the JAPS again. Okay. In the JEPS file, in the size, fx
Yeah,
size
go
was
on.
successfully computed from 0 to out of 20 data entries. You see in the write down?
Actually, 1 minute, something happened. It's everything gone.
No, calculate again. I think something wrong with your, because you have multiple files open, right?
Yes,
Can
yes,
you
I will.
close the one file that is JEPS, close the other files?
Okay.
Yeah, you have multiple files open.
Yes, yes. Yes. I think I need to upload again.
Mhm. Yeah, this one, I think so. Yeah, this one. I
File
think
in
the data file
use.
is open, yeah.
It's now opening new.
Hmm. Hmm.
Okay.
Yeah, you have so many files opened.
Yes.
Go to the
So-
meta, spec size computation,
yes.
go to the single group, mean.
Yes.
Just wait.
Mm-hmm.
Yeah, wait. So the fx size were successfully completed from 0 out of 20 data entries. The fx size already calculated. Just hold on a second. The fx size is computing. You see?
Okay, okay.
Why it is taking so long time?
Maybe some issues with my jabs.
Yeah, I think so. But anyway,
Mm-hmm.
I think go to the option just to check. Go to the option in the right hand
Option.
side. Yeah, this one option. Yeah, you can see that there are some computed columns. Name will be fx size, standard error, fx size. These are the computed column. Go to the data set. Once it is done, the data set, go to the data set. Edit. Yeah.
Edited.
Yeah, calculate the edit data. Okay.
Mm-hmm.
The fx size, no. You analyze, yes, analyze. You see the data is still analyzing. I'm not sure why it is taking too long, but you see, click the once it is done,
Mm-hmm.
you click the this is the small arrow in the
Yeah.
middle of the interface. You see the small arrow,
Uh-huh.
middle of the interface.
This
Small
one?
arrow. No. Small arrow in the left side. In the left side. At the left side, small arrow. Yeah. Go to the left, extreme left. Yeah, go to the middle of this line.
Oh, I'm not getting.
Okay. In the middle of this line, if you click the small arrow, the triangle, if you look at the triangle, not here, not up. In the left side, yeah. You see there is a just next to the left. Yes, this one. Click this one, show the data. Click this one. Yeah,
Show data.
data. Right. Click this one. Now, in this case, you will see that there is a column will be calculated for the fx size. Okay. The column will be calculated for the fx size. I'm not sure what happened to your JEPs, but let me try from my side and share it
Okay.
with
That's
you.
better. Okay.
Okay. Anyone can try with me, or anyone can demonstrate how to calculate the fx size using this number of information. Anyone?
Okay, can I?
Yeah, you can close it. You can close
Okay.
it. You
Okay,
can
fine.
close it. You
Sir, I
understand?
cannot sir, I
Yeah, I
cannot share the
understand.
screen, but I calculated it. I just as you guided, I did it.
Yeah, you can share with us.
So I cannot share it. I'm like playing the video in the different device, and
Oh, okay. So did you calculate right?
yes, sir, I tried, but my JAPS is also having some issues. But I just like on my first attempt I tried, and it is showing a different column of calculated effect size and
Yes.
calculated outcome.
Yes, that is what we are trying to find out. Okay, that is what we are trying to find out from our analysis. Understand? So I think everyone from today in the next class, I really request everyone to first calculate the effect size column, which is a important aspect of our study, and this is very important for everyone because without the effect size calculation, it is difficult for us to um, run any type of analysis. And there are so many analyses available for this meta-analysis. And we are talking about, we are going for not only classical, we also move to the, how do I say, the Bayesian. So that is also a important part of our study. So this is very important, and it is, in my opinion, everyone at home should try the effect size calculation, because without the effect size calculation, it will be difficult for us to having a good understanding of what we are in this case. So let me share my what I said. Let me share my screen with you. Okay, let me share my screen with you again. Okay, so can you see my screen, the learners?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So you see the computed effect size, computed standard error, computed effect size type. So there will be something like this column. Okay. And you see anxiety disorder. Our first effect size is anxiety disorder. Look at it. You are looking at, right? The anxiety disorder, the effect size is calculated, correct? The effect size is calculated. Now, if I go to the analyzing, if I go to the analyzing again, you see from here, you can see the drop down menu, right? Now, if I say blood pressure control, if I calculate the blood pressure control, okay, so there will be another effect size will be calculated. So if I look at the blood pressure control from this effect size calculation, blood pressure control, what is the blood pressure control? Where is the, you see blood pressure control? Look at the blood pressure control. You see the blood pressure control effect size is calculated. Now,
Yes.
right? Since it's
Mhm.
not, since it's not a study of one single group of topic, meaning that the articles are not homogeneous in nature. We are not talking about fitness study, all the fitness study. No, we having here study name like cancer, depression, pain management, cognitive, weight loss, anxiety, so many things in one single demonstration. But usually what happen when we download the article, we download from a single topic. For example, if somebody studying on the fitness study, they will download 50 studies based on the fitness study. In that case, the effect size column will show all these column empty cells will be calculated. But I hope you understand that how to calculate the effect size, and the effect size will show in which column of your data set. Is it clear to everyone?
Yes, yes.
Yeah, because from here you see study level, there are so many study level, but normally this is not the case. Normally what happened, we have a single 50 study downloaded, but all in one single concept. Maybe we're talking about cancer screening, depression treatment, fitness study, one of the single concept, all 50 studies will be like that. In that case, there will be no like this drop down. There will be only one single name, let's say blood pressure control, and the column of the effect size will calculate it for all the values of all the rows, the MP rows that has. But now the effect size is calculating by study by study. So whatever we
I have.
want, For instance, in this case, if I say the quality of the life score, the study will calculate. Now you see that the quality of the life score is calculated for the effect size. Understand?
I have a doubt.
Yes, please.
Actually, in your data, you
Mhm.
made it as a study ID 1 to 20 and
Mhm.
study name. If I'm having the anxiety and disorder, for example,
Mhm.
I'm having 20 studies, and
Mhm.
but 20 studies having different study names are there.
Mhm.
So
Mhm.
if the same way we are doing the same thing, subset level will be 20 names will be there. Correct.
Mhm. Mhm.
The same issue will be there.
No, not same issue will
Mhm.
come. The
Mhm.
actual data set look like this. I tell you how. The actual data set, let's
Mhm.
say go to the open data set, go to the computer, sorry, the data library, go to
Mhm.
the meta-analysis and take this one as an example. Okay, 13 studies on the
Okay.
BCG drug study. Okay,
Okay.
BCG drug study. Okay.
Mhm.
So now let us wait for the JEPs to come the
Okay.
data set. So we have this data. You see, in this case, the author,
Yeah.
Anderson,
Okay.
Ferguson, all these are authors. They're talking about the BCG drug study, right? Now,
Okay.
once we have the treatment group column and control group column, and you see
Mm-hmm.
the computed effect size for
Effect size.
all the values.
Okay.
And also computed standard error for all the value, like this, the one that we just calculated, right?
Okay.
And the study level, instead of, in this case, we say now depression, blood pressure, it is not the case because we are talking about one single study, the effectiveness of the BCG vaccine against
Okay.
tuberculosis. So one single concept, but from different
Uh-huh.
studies, Arneson, Ferguson, and their names are there here. So we did
Oh.
not put in our data like this. That's why there's something wrong in our effect size calculation. Some are empty, some
Oh.
are coming. You see here, there is no author's name. Here only
Oh.
the study concept are there, like fitness study,
Okay.
cancer skin, but there is no author's name. But if we put the
Okay.
author's name just like this one, it will be
Uh-huh.
calculated like this way. Is it clear to
Okay.
everyone?
Mm-hmm.
Your doubt
Okay.
is, your doubt is clear?
It's clear once I am doing it will be okay.
Yes. So do it. Okay?
Okay. Mm-hmm.
Okay. So any other question? Nabeen?
Yes, sir. Mine.
Any
Hello?
question? Yeah, I'm listening
Yes,
you.
doctor.
Yeah.
Okay.
Any question?
Yes, doctor. Mine is not showing only T test, or no, only showing my just software, doctor. May I share my computer? Just
Yeah,
1 minute.
please share.
Doctor, my screen is visible now?
Yes, I can see your screen.
Okay. There is no any meta-analysis and all, doctor. This only shows descriptive T test and
Oh,
all
okay.
like.
Right to the plus button. Go to the plus button.
Okay.
Yeah, okay. Go to the meta-analysis. Check the meta-analysis list here. Check all the boxes.
Okay.
Click all the boxes. Whatever inside this right now. Click all the boxes. Yeah, click it. Like this. Hmm.
Okay. Okay. Now meta-analysis. Okay.
Hmm. Hmm.
Hi, sir.
Hmm.
For our practicing, we are doing one studies. We are downloading the article when we extracting. For
Hmm.
that, if we don't want to take the only single data is enough.
Yes. Let's say your data set is about the
Social
anxiety,
anxiety. Yeah.
social anxiety affecting maybe some
Adolescents.
adolescents.
Yeah.
Yeah.
Mhm.
In that case, you have a descriptive study column, right? And in that
Yes.
column, you may have a table. In that particular table, you can collect the mean value and the standard deviation value and number of sample size, right?
So
And
we don't want to take the randomized control trial studies and all.
no need, because we are not taking any two different mean. We are not taking. We are taking only
Oh,
one single mean.
one single. Okay. Okay.
Doctor, he is showing a group 1, group 2 like this.
Oh, okay. So go to the design. If you go to the design, go up. Naveen, go up. No, not here. You see step 1. You see the step
Okay.
1. Go.
Okay.
Yeah. From here, you go to the single group.
Okay.
Fine. Quantitative. Now you will see mean, standard deviation, sample size coming, right?
Yes, doctor. Yes, doctor.
Yeah. Mean, then standard deviation. Go to the standard deviation. Yeah, standard deviation, and then sample size. And since we have not taking all the is the study names, study name or study idea. Click this one. Now here you understand what I have said just now, right? But because
Yes.
we are not taking one single concept and all the author's name, we have different concept. Therefore, here you can see that subset level anxiety disorder. So the effect size is calculated only for the anxiety disorder. So if you go to the triangle, click the triangle, you will see the effect size is already calculated. Not this one, the left triangle. Go to the middle of this one. Fantastic. Show the data. You see the calculation is already done. Anxiety disorder, your effect size is calculated. Your standard error is already calculated, right?
Okay, doctor. Yes,
Okay.
good.
So once we go for the random effect model or a fixed effect model, we are going to use this column. But since, as I told you, that our data set is not on the same concept, it has different concept like fitness study, cancer, depression, pain management. But normally this is never happened for a meta-analysis. Meta-analysis, what happened? One single concept, but different articles on that particular concept. Like the one that I shared with you, BCG effectiveness on the tuberculosis study. You understand what I'm trying to say here?
Yes, doctor. Thank you, doctor. May I
Very
stop
good.
my sharing?
Yeah. Please go ahead. Zohura, understand?
Yes, sir, but I am having a problem in finding the computation in my JAS.
Can you share your
I
screen,
share? Yes.
please? Siddharth,
Yes, sir. I think it's clear to me.
fantastic. Go to the meta-analysis. Analysis. Click the analysis. In the top right left corner, analysis. Now go to the meta-analysis. Go to the meta-analysis. Go meta, right. Go to the meta. Yeah, this one. Go. Oh, okay. What I know what is the problem. You have downloaded the older version.
Okay,
You have
now I
downloaded
have
the
to
older
update
version.
it.
Yeah, you have to
Okay,
update the new version. New version, it
okay,
has
sir.
effect size calculation.
Got it. Okay, sir. Thank you.
Good
I'll do
question.
that.
Yeah, good question although. Download the latest version from the JAPS website. And JAPS
Sure.
is as I told you, JAPS is the single most important and the comprehensive software for both classical and Bayesian meta-analysis. Once you finish this course, once you understand the classical and Bayesian, I'm sure you will be master on this particular subject, and you can teach, you can make projects, and so many places, especially in the medicine, people require the expertise of knowing meta-analysis, and they pay a lot of money for analyzing the meta paper. I remember one of my professor, although I do not do that, but one of my professor just to analyze these things, that the one that I'm now sharing, $500 for calculating the effect size and calculating the random effect model, explaining those things. $500 for one single meta-analysis paper. Can you imagine how much money you can make if you know the mastering the whole thing? And the interesting part, the important part here is that only this subject AI cannot do anything, because you see the AI, you upload the data, or you can say collect the data for me. AI can do the existing data set from the secondary sources. They can extract publicly available data. For example, World Development Indicator is publicly available data. So AI can take data from the publicly website. But the meta-analysis or systematic review, this is not publicly available. You have to go to the database, like the systematic review that I shared, download the articles, collect or extract the data, make an Excel file, then only you can use to compute it by JABS or any other AI. Otherwise, it will never happen, right? So this is a very fantastic, authentic, original research methodology. Nowadays, the AI era, the chance of publication in a Q1 journal is so much by adapting this methodology. Understanding what I'm trying to say, my dear learners?
Yes, yes.
Yes. Yes, sir.
Okay. So
Yes,
one
sir.
last thing before we leave, one last thing. Can you see my desktop?
Yes, sir.
Okay. This is one
Yes,
of the
sir.
paper that I'm currently writing, and I am hoping that one of you may join me, or maybe everyone will join me in this particular research if your interest is there, so we can publish it in a Q1 journal. It's almost done, but we need some things that we have to do, like cross-checking the studies, cross-checking the referencing and all those things. So this study, if you look at the study, is talking about artificial intelligence adaptation readiness and strategic AHR outcomes, a Bayesian meta-analysis framework for information system implementation. So I'm just sharing how a meta-analysis Q1 standard research paper you should write. So you
Okay.
start with the abstract and keywords, then introduction. In the introduction, we jump into the results. You see the results are given here, since it's a correlation that we're talking about readiness and the association of AI application, then research objective and research question. Then we have methodology. You can see that search, strategy, and systematic study selection process. I told you in the first class that Prisma is the way we can design our systematic literature review. Also, I told you that Boolean study, remember Asifa demonstrated in the last class how to do that from the PubMed, right? So similarly, you can do that for the Scopus or Web of Science. I have write down that part as well. Then you comprehensive exclusion criteria, how you excluded it. The systematic literature review identified 287 potential relevant publications through comprehensive search for Scopus and a Web of Science database. Since I have this access to the two of these databases, so I downloaded from the article, but you can use OpenLX itself is very good. Semantic Scholar is very good. Then data extraction, systematic study, coding. Then we
1
have
minute, sir.
yeah.
How many studies you took? 15
Yeah.
total.
Yeah.
Okay.
Yeah.
Okay, 15 is enough?
Enough.
Oh,
Enough.
okay.
Sir,
Enough.
sir, one more doubt, sir.
Yeah.
Sir, I'm Naveen. Sir,
Yeah,
is
Naveen.
there any minimum number of study is we have?
20. In my opinion, 20 is good. If it is a very recent topic like AI is a very recent topic, right? So
Yes, sir.
not much articles published on this topic, right? So in this case, 10 to 15 articles is good. But for general topic, for let's say anxiety disorder or malnutrition, or maybe in your field or sports science, Jackie is doing sports science. Okay. So in that case, in my opinion, at least 20 studies you should take for meta-analysis, because you see for the T-test and Z-test, there is a minimum requirement, right? So in my opinion, 20 studies is sufficient. Some good journals also publish less than 20 studies, but not less than 10 studies. That is not a comprehensive.
Okay, if maximum any numbers?
No, there is no maximum numbers. Higher the maximum, the larger is the better. The larger is the better, because, and you see, it depends on how you exclude and include your studies in the meta-analysis process. So Prisma is very important. You should follow the Prisma very carefully, because the reviewer will ask that, are you exclude any study that is important? Right?
Okay.
And also you remember in the first class, I told you the duplicate articles. Sometimes what happens,
Yes.
same article
Duplicate.
published in 2 different databases just to change the title. Sometimes it happens. So if you are including those articles for twice in one single data set, then it is very difficult to get a publication. And nowadays, you have to share the data set to the publisher. There is the OSF. You remember the OSF? This is called the data set, OSF data set, file sharing. So that is,
Yes.
you have to share your data set, entire data set, with the publication Q1 journal editor. So they will justify, go and search those articles, check each and every number of sample, number of mean, number of standard deviation. After that, they will send it to the review. So it's not a very, straightforward case.
Yes.
Okay. So you see, I write down a simple Bayesian meta-analysis formula, which I will share with you normally in the later stage. So this is the results, and the result shows, you see, there are different studies. You see the number of studies, year, number of sample size, industry, country. R is the correlation value, which is in this case my effect size, okay, and the confidence interval value. Then the classical random effect model. Since I have the effect size, so I go to the random effect model, and the random effect model result shows this one. I will explain that in the next class. Maybe tomorrow we will start doing that. And then we have this forest plot, which I will explain later on. Then we have the publication bias plot, which I will of course explain to you. Then we have Bayesian part, which I will of course, part of this, our course is Bayesian also. So this is another table for Bayesian one. Bayesian distribution are also given over here. This is a Bayesian evidence distribution, which I will explain to you. So a fixed effect model and random effect model, you see 90% case people using random effect model in their studies. Just now I told you, right? 90% cases random effect model is used, 10% cases fixed effect model is used, which is also in my findings, it shows that, right? So that I also explain here, the discussion part, and then I conclude on practical implication. Then I write that the references that I have choose. So then we have declaration of AI is very important. I declared the AI that I have used Grammarly, Quillbot, Manos AI in order to fine tuning my academic writing and explain the results more accurately. So this declaration gives you that you are honest, ethically sound, and Q1 journal, especially the Elsevier Q1 journals, they liked it very much. So you have to declare that how much percentage of AI that you have used and for what purposes that you have used in your study.
Okay, I have a doubt.
Yeah, please.
Actually, while we are using Grammarly after writing the article, again the dictation score is coming.
Yeah.
So is it okay? Because
Yes, it's okay. It's okay.
okay.
It's okay because journals allow Grammarly, Quillbot, any fine tuning of the academic writing tools. AI,
Up to what percentages we can use? We
40,
can make
40%, 40%, 40%.
Okay. So we don't want to concentrate on 20 because
No.
after doing
No. The standard or accepted version of the rule of thumb, because I have so many articles published, so many are on the list. Hopefully in the next couple of months, you will find that there's so many Q1 articles are coming from my side. So in those cases, I use AI, like Notebook LM is the AI, Manos AI is the AI, ChatGPT is the AI, Cloud is the AI, right? I have used it. But I also acknowledge it. What is the percentage of AI that I have used? Normally in the meta-analysis, you cannot collect the data without using the tools and technique like Notebook LM, you have to use it, right? So that is not an AI. That is not your AI writing concept. You are not going to write your literature review based on only Notebook LM. Probably you have to download, check, and revise it based on the protocol, right? So those are the things that you are doing by yourself. So overall, 40% of AI is acceptable to all the journals in the world. I tell you, and it is confirmed, you can use it 40% of AI for your publication. And for plagiarism, it is of course less than 20%. It is of course less than.
It's okay, but we are now stuck with the AI score.
Yeah, AI score is 40%. More than 40% is not, how do I say that? It is not advisable. It is not advisable.
Actually, I shared with you one of my paper. It's already finished the second review. Once they came the paper, it's a Q1 journal. Came for the second revision. Once I checked the plagiarism and all, it's showing the 100% AI.
No,
But
you see,
journal is accepted now. It's no problem. It's
Yeah.
99% Scopus.
You see what happened actually, Asifa. Once you submit to any journal, any article to the system, the system itself are connected with the AI, right? So the
Yes.
revision part, when you are going for revision, it will show that there is a high percentage of AI presence. So never mind with that. Initially, when you are submitting, check it. And if it is 40%, or let's say around close to the 50%, you are very safe to
Okay.
submit to a good journal.
Okay, fine. Okay, thank you.
Okay.
Then one more doubt about meta-analysis is there. I saw some articles related to 3-level meta-analysis and meta-SEM analysis like that.
Yes. MetaSem, we will do it later on, because once you grasp the basic understanding, you can also take the MetaSem analysis, and you know that in JABS we can do that as well.
Okay.
There is an
3-level
option.
meta-analysis and all?
Yeah, everything is in the JABS available. 3-level is the network meta-analysis, and network
Yes.
meta-analysis you can done by JABS. I have other softwares for meta-analysis, network meta-analysis. There is a dedicated platform for the network meta-analysis, which I will show. One of my video also, I shared the network meta-analysis. There I shared that there is a dedicated what do you call the platform for network meta-analysis, for 3-level meta-analysis, which I have this video, but it is more advanced. I hope we will get there as well, but slowly and gradually.
And because of you, this year I'm planning full of meta-analysis and systematic. It's in advanced level I'm planning this 2026.
Thank you. Most welcome. So,
And I'm
yeah.
okay to go.
Sir,
I'm
sir,
ready
I
to
have
be
one
with
doubt.
this article.
Yeah, definitely. Most welcome. Yes, any doubt?
Sir, as you said in the very first class about the Prospero registration, I prepared a template. So can you correct the mistakes if possible?
100%. Send it to me. You have my email address, right? And you can
Sir, I
also
sent in the
WhatsApp
group.
me.
I sent in the group. So should
Yeah,
I send it?
group, or I think you personally send it to me, my WhatsApp.
Okay, sir.
I'll double check. Don't worry. Prof. Mahmuda, madam, do you have anything to add or any question? Professor Mahmuda, madam, are you there?
Doctor, I have small doubt, doctor. If you
Yes, Radha, please.
Yeah. Question number one is, if I'm doing the PhD dissertation, may I use the term like a related literature review, or I can mention systematic review in my report?
Okay. If you are following systematic review, like the one that I started this course with the first class, okay. If you are following the protocol, if you are following the steps like Prisma shows, you have to mention upfront the title of the heading of your section should be systematic literature review. You have to mention that. There is no other things that you can mention. You have to write systematic literature review. Apart from that, let's say you are taking random articles for narrative review. In that case, just write down review of literature. Okay?
Doctor, yes, doctor, good. If you possible, kindly share a SLR, any published paper articles, SLR with the meta-analysis, possible, share in the groups, doctor.
Yeah, definitely. I have my own article, SLR and meta-analysis as well. So I will share it with you in the group. Don't worry about it.
Thank you, doctor.
Sir, as in the JABS software, as we saw that there are many data already uploaded. So like, can we learn from it? Like how the things.
Yeah, definitely you can do that, because the one drawback of the JABS, the data set that it does not have all the effect size calculation. For example, it might have a mean difference. It doesn't have the correlation. It does not have odds ratio, risk ratio, Bayesian. These are the things are missing in those sample data set. Sample data sets are only showing the very basic level analysis. So that's the reason why I am interested to share those information with the data set and with the instruction in this particular course, so that you can do it by yourself. Because you see, the meta-analysis is a very large subject area. And in this particular subject area, if you choose only one single group study, it might not be a good idea. There are many RCT studies, there are many variable association studies. Like, for example, in economics, we have the relationship between inflation and economic growth, right? So inflation and economic growth, when we're talking about relationship between economic growth and inflation, of course, we're talking about the variable association. And when we're talking about the variable association, of course, there is a correlation should come into the picture. Similarly, if say that the drug is working or not, so yes or no type of answer or outcome, then in that case, we need odds ratio or binary outcome like risk ratio or odds ratio, right? So all these things are different depending on the research question that you have in your research. So the more you go deep into the matter, the better you understand the things. And Jeff's sample data set are only few of those examples, not everything is given there. So it is a drawback, limitation, but not to worry. As I am here, inshallah, we will try to give you all this information that is required. Okay?
Okay, sir. Okay.
Any other question? Jackie, where is my Jackie?
I have one more question.
Yes.
Yeah, anyway, we are downloading, we are finding the research question, and we are based on that we will have a search string.
Mhm.
Then we will find some article. We will finalize maybe 20 or 50, 25 articles.
Mhm.
My doubt is that while we are writing the introduction and
Mhm.
other research gaps, whether
Mhm.
we need to use only that article or we can use any other article.
That's a
We
very,
can cite.
yeah, okay, that's a very good question. That is a very good question. Now,
Mhm.
there is no harm to use different articles apart from the one that you are using for meta-analysis. The meta-analysis, let's say you are using for 20 articles after screening, you end up
Mhm.
with 20 articles for meta-analysis. That's fine. But let's
Mhm.
assume that you're talking about a theory, right? And
Yes.
theory was established in 1960s by someone who actually invented this theory. So you have to mention that theory, right? In your
Yes.
introduction, that I'm motivated from this theory and I'm trying to testing this theory. So in 1960s, theoretical article that you have you are saying, you need to mention that as a reference to your research paper. So 1960 theoretical paper is not part of your meta-analysis, but part of your motivation to study for your research, and therefore you can of course cite this 1960 research article.
Then I'm finding some other articles which is not in the list, but we do have a more citation and more recent works I'm finding. So I can use that citations as well.
Welcome, most welcome to do that.
Okay. So is it essential to be cite all the article which is using
No,
in
no,
okay.
no,
Okay.
not. Good question again. No,
Okay.
there is no essential that you have to cite all those articles, because these are just your collecting of the meta-analysis statistical information.
Okay.
Not every article is equally important to get some insightful information for your literature review, narrative literature review, or writing introduction, or maybe conclusion, or maybe discussion part. It may not be, not all the articles are equally important. Maybe few articles are important, but not many, not all,
Many.
not all.
Okay.
In that case, the main focus here is to use the articles for only meta-analysis purposes. Other cases, you are free to use anything that you wish for.
Okay. In some topics, while we are searching, there is lot of meta-analysis papers are there. So we can gather all those meta-analysis paper. We can write another paper based on this meta-analysis
Yeah, that is what we call the umbrella literature review.
review. Okay, fine. Okay.
That is
So,
what we
like,
call.
where can we find like as you have already published many papers in the economic sector, I like went through the things which you shared in the group. But so like as I want in the medical domain, so like the things that we are learning, like as the example today, the independent group and the types of model, like when how the doctors have like correlated in their own study, how can we access their data set, or it is not possible?
Okay, first of all, you need to select which is the study research question. Let's say your research question is about the papers which use the research methodology as RCT, randomized control trial, let's say. And you are thinking about a pain relief drug related study. Pain relief drug, and you can make any specific pain related drug name, or maybe a generic name of the drug comes from, and then say that this is a study of a randomized control trial. Now, this keyword, randomized control trial, drug name, and the research question that you're looking for, effectiveness, for example. These are the keywords you can put it in the PubMed or Scopus or Web of Science. Now, once you put those keywords, there will be few articles come up. Now, you go to those articles and download those articles. Since these articles have RCT, these articles have effectiveness, and these articles have the control group and the treatment group information in, because it is RCT type of study. So those articles have the data set in the article. In those articles have the data inside the article. Now, once you download those articles, go to the notebook LM, upload your article one by one or as a group, and then what you can do, ask the AI to extract the data for you. So what are the data set you need? You need the data of the mean value of the control group, mean value of the treatment group, standard deviation of the control group, standard deviation of the treatment group, and sample size of the control group and sample size of the treatment group. So the information will be given from the notebook LM, extracting the information for you. And you can put that data set into the Excel file, the one that we design it. You have to design it like this way. And therefore, I told you that it is always good to collaborate with other researchers, because if you do it manually by yourself, 50 articles, if you screen through and collecting data, it will take a long time. But if you collaborate with someone and divide the articles among your authors, it will be quickly done. And also, it will be more effective way of writing a research paper in the case of systematic and meta-analysis. So this is how you can collect the information and design the research Excel file. Once you design the research Excel file, then only you can go for analysis. You may ended up very few articles in your title. Let's say you have ended up with 5 articles only, which has this type of data set. So in that case, you have to change your keywords. You have to change a little bit of what you are looking for, maybe changing a little bit of in a different direction to collect the information from those articles. And that is the why it is really a holistic and comprehensive work, because you cannot just straightforward go and collect the data. It's not like that. You have to go fast, trial and error, and then you may have ended up with few data. In that case, you may have to change few keywords and go again and again download the article. So that might take a little bit of time initially, and therefore it is always good to use 1 or 2 researchers. So one is looking for the articles from the PubMed, one is looking for the article, let's say, from the OpenLX, and both downloaded the article, then check the duplicate articles, and then collect the information from those articles separately, divide the articles, and then you come up or end up with the data set, let's say 17 or 18 articles or 20 articles might have this information that you're looking for. And that is sufficient for you to analyze and come up with some results, whether it is heterogeneous in nature or homogeneous in nature, or how significant is the heterogeneity, or how significant is the homogeneity. Those sort of information you can end up with analyzing the 20 articles that you have downloaded. So in meta-analysis, not always you find that 50 or 60 articles are there for meta-analysis, because most of the cases the data set are missing. So you might not get the required data. So in this case, 17, 18, 20, in my case, 15 I have used. So that is okay. And I have a justification why I ended up with 15 articles, because in the Prisma, you see there is a step 1, step 2, step 3, right? And at the last step 3, I said that this is the reason why I ended up with 15. Initially, I have found 300 articles, but after screening all those articles, I may ended up with 15 articles for the meta-analysis. And that is what I have found. And that is okay for analyzing and publishing your research article. Clear?
Yes, sir.
Yes, sir.
Yes,
Clear.
sir.
Okay. Where is my Jackie?
Sir,
Jackie?
I have a question.
Yeah, let us hear from Jackie. Jackie is sleeping maybe. Where is Jackie?
But Professor, I'm listening.
Okay,
Uh,
okay. Sometimes you have to say something, otherwise, how do I know Jackie is awake or not? Okay, Siddharth, any question?
Sir, before we actually extract data and prepare for meta-analysis, first we
Yes,
have to do systematic literature review.
yes,
So in that, first we will suppose I download an RIS file and I get 1,000 articles.
yes.
So with that, first I'll do title and abstract screening and
Yes,
and-
let's say 1,000 articles you are downloading, but 1,000
yeah,
articles you are downloading based on what? Your research
based
question.
on based on my search query.
Yeah, research
Research
question.
questions, of course.
Research
Yes,
question, yes. So your
right,
research question should be very much narrowing down. I told you, right? It should be very much narrowed down. If
right.
it is not narrowing down, very focused or not very narrowing down, then you might ended up with 1,000 articles. And from 1,000 articles, inclusion, exclusion criteria and screening, it may take long time. So it is always
Yes,
good to narrow down your research question as much as possible. As much as possible. Like, for example, if you know that the methodology that the research articles that you're looking for is RCT, let's say, or you know that the methodology is only regression analysis, just mention that while you are downloading your article. Then the article will be first already filtered out while you are downloading based on the keyword that you are putting. So the keywords you have to put very carefully. That
right,
then you will get a article that is more close to the research question, and therefore you can easily collect the data that you need. But if you just write random keywords and random title, you ended up with 2,000 articles. Okay,
right,
and from 2,000 articles, you never know. You will never write a research paper from these 2,000 articles because it's very hard to screening 2,000 articles, right?
right.
And
So
and
then,
and
roughly,
also
yeah.
Siddharth, I one thing I would like to add up before I listen to your question. You
Mhm.
physically go and download the article. That is also very important because you see in the
Right.
notebook LM,
Mhm.
if you cannot upload the full PDF file, then how can
Right.
that AI extract the data for you?
Exactly, exactly.
It cannot extract from the RIS file. It cannot extract that. It cannot possible. RIS file is good for Zotero. I told you in the first class. RIS
Right.
file is good for the Zotero, and this Zotero can be useful while you are writing your research article. Put the reference inside the paper. And
Right.
the RIS is only good for that. It is not good for
Right.
meta-analysis. It is not good for writing research paper or notebook LM. Understand?
Right. Right. Right.
Now
Sir,
continue.
actually, I was going through some systematic review papers,
Yeah.
wherein they have mentioned a process. First, they are downloading, say, 1,000 or 1,500 papers,
Mhm.
and then they are screening the title, keywords, and abstract.
Mhm.
Then they reduce the articles to, say, 300.
Mhm.
And for those 300 articles, they are downloading the full text. And
Mhm.
again, they do the full text screening. And
Mhm.
after that, they'll be left with 50 articles,
Mhm.
50 or 20 articles. And
Fantastic.
from those 50 or 20, they will extract the data and perform meta-analysis.
Yes.
So this process is very time taking, at least a month or two, maybe more.
Yes, that's why you hire
Yeah,
people. You hire people. You collaborate with the researcher. You collaborate
right,
with
right.
other professors and teachers who are expert in this particular field. You cannot do
Mm-hmm.
it alone. The first principle of any systematic literature review and meta-analysis is not to work alone. The first principle.
Right,
The first principle is that you have to work with someone else. And there is a word called kappa. You remember, have you heard about that
right,
word?
right.
There is a
Sir,
kappa.
sir,
Yeah,
exactly.
cup.
Integrator reliability. Yeah.
Exactly. Kappa is
Mm-hmm.
a reliability test, right? I'm sure some of you heard
Right.
about this kappa, right? This kappa
Yes.
is a reliability test. So why we are talking about reliability? Because if only one researcher is doing all those things, there is always bias. There is always chance of mistake.
Right.
Okay. So you hire someone who is a co-researcher or maybe a research assistant to help you.
Mm-hmm.
Otherwise, the first principle is not to do alone the systematic review or meta-analysis. Don't to do alone. try to
Right.
collaborate with at least one other researcher.
Right.
Okay?
Yes, sir.
I
Yes,
think
sir. Yes,
I
sir.
think you are enjoying my class so much that 2 hours
Absolutely. Absolutely.
has been passed and you are not leaving me. You are like a
Absolutely, sir.
glue sticking to me for 2 hours.
Right.
Of course,
Uh,
so we are getting more doubts and it's getting more clear now.
Okay, dear. So I guess we can stop here and probably tomorrow we
Yeah.
have same time 8 p.m. class. So let's
Yeah,
have
for tomorrow, we need to extract the data for our study and compute the effect size. That will be the homework.
yes, and I really want you to do
Okay.
one thing more is that once you download the articles,
Uh,
once you
uh-huh.
download the articles, you keep the articles in one folder, okay? Then in the
Yeah,
class,
yes.
what you can do, use the notebook LM or
Uh-huh.
the video I shared with you that how to extract the meta-analysis
Yes.
data easily, right? So there are
Okay, yes.
one or two more how do I say the software or the platform are there. So use those
Okay.
and extract the data in front of us,
Uh-huh.
sharing the screen
Okay.
so that we
Okay.
all can learn.
Okay. Actually, yesterday I tried with OpenLX,
Mhm.
but unfortunately, when I am trying to log in with OpenLX, they are sending the link to email
Mhm.
while exporting the data.
Mhm.
But I'm not getting any link from OpenLX, but I
Mhm.
contacted reply from them.
Mhm. Yeah, no
So
problem.
OpenLX having that
OpenLX,
yeah.
OpenLX, the RIS file, it will send it to your email. Yes, it is true. But the PDF you
Yeah.
can download very easily. There is a systematic scholar, you can go for it. You can go to the oa.mg to download the articles. These are all free. PDF are available, and for systematic review, these are very much accepted by
Now
the
I
good journals.
then I Yeah, now I used actually yesterday there is a problem with my Scopus proxy,
Yes.
institution proxy, so I
Mhm.
cannot use Scopus yesterday. Today it is okay. Then I
Mhm.
used PubMed to share. Only PubMed yesterday I used.
Mm-hmm. No, that's fine. That's fine.
Yeah.
And these are all accepted.
Mm.
I mean, as long as you give the
Okay.
justification, all are accepted.
Okay.
There is no harm. You
Okay.
see,
Fine.
the first thing of the research
Okay.
is to be honest. The first thing.
Okay.
If you are
Okay.
dishonest, like you're downloading article from
Okay.
Semantic Scholar and reporting
Uh-huh.
in your research paper that you are downloading it from the Scopus, that is wrong.
Okay.
That is wrong.
Okay.
Whatever you have
Okay.
done, whether it is OpenLX, whether it is Semantic, whether it is OA.mg, but be
Mm.
honest, saying that yes, I don't have Scopus, I use this
Mm-hmm.
OpenLX because it is free and available. There is no harm.
Yes.
Nobody will tell you that why would you do that. Nobody will tell that. Why? Because
Okay.
it
Fine.
is understandable that Scopus is expensive for the institutions to having it in developing countries like us and many of the institutions all over the world.
Mm.
So
Okay, today I already have the PubMed data and I will use Scopus also to Scopus today to download the data. That's okay.
no problem. And then you share how to extract the data is tomorrow by using the notebook
Okay.
LM. And also please have a look the video that I shared in the extracting the meta-analysis data easily. In that particular video, I shared one or two more platform to extract the data. One of the platform called the Tabulo to collect the data, like for example, the data set of the tabular
In
data set, it
YouTube
will
video,
extract. Yeah, in my videos, you will find out that I
in
already shared
you.
it. Yeah,
Okay, I will
yeah.
find out.
Yeah, I already shared it in the group. So check that and
Sir,
yeah.
Group. Okay.
Okay,
sir,
and
can you
then
share one
Okay, I
more
will
time?
share.
yeah, I will share it one more time. Don't worry. Don't
Okay, sir.
worry.
Thank you.
Okay.
So any other
Thank you, Professor.
question?
It's a long time we are taking for you.
It's okay. It's okay. No problem. As long as my Jackie is here, I'm happy. Jackie, are you happy?
Yes, I'm here, Professor.
Okay. Are you
Yeah.
happy? Are you happy with the work and understanding things that we are
Yes, I
talking
can
about?
understanding.
Okay,
Yes.
very good, very good. So thank you,
Yeah.
Asifa. Thank you, Zahura. Thank you, Zaki, Radha, and Naveen, Palash, everyone. Start for wonderful session. Hope to see you again tomorrow at 8 p.m. Okay?
Thank you so much. Sir, please share the
Okay,
class
sir.
3 slides also.
Okay, I will. I'll give you the Google Drive link and today's video as well with the subtitle for Zaki. in YouTube private link. Okay. Thank you.
Good night.
Good night.
Thank you, sir. Thank you.
Thank
Good
you.
night.
Bye-bye.
Thank you,
Okay.
sir. Thank you, sir.
Okay. Bye-bye.
Thank you.